Good morning, beautiful and handsome students. Welcome to Calculearning. I am Miss Getchon, and today my fellow teachers and I are going to tackle about one of the fundamental topics and skills in calculus, which is finding the derivative of the function. To start, let's begin with differentiation. Miss Despy, could you explain to us what is differentiation?
Differential calculus is concerned with the problem of finding the rate of change of a function with respect to the variable on which it depends. It involves calculating derivatives with the aid of rules, which are constant, power, constant multiple, sum, product, quotient, trigonometric functions, exponential functions, and the chain rule. This is used to make things easier to solve. Derivatives are traditionally solved this way. The derivative of the function f, whose value at the number x in the domain of f is given by f prime of x is equal to the limit as h approaches 0 for f of x plus h minus f of x divided by h.
Very well said, Miss Despy. For differential calculus, let us have this one example. Students, we have here the function of y is equals to e to the x sine x minus 3e to the x cosine x. Quite tricky, isn't it? We have here Miss Sideriosa to solve the first derivative of the function and Miss Elia for the second derivative.
By the looks of it, we can already tell that this is an exponential function because of the presence of e to the x. Rule 8 states that if f of x is equal to e to the x, then its exponent on the derivative will not be affected, unlike power rule, wherein you need to minus 1 the exponent. The first thing we need to do is to apply the product rule, which states that the derivative of the product of two differentiable functions is the first function times the derivative of the second function, plus the second function times the derivative of the first function. Since we have trigonometric functions, we will need rule number 7 that states the derivative of sine x is equal to cosine x and derivative of cosine x is equal to negative sine x. That being said, the derivative of e to the x and negative 3e to the x stays the same according to rule 8. Sine x turns to cosine x and cosine x turns to negative sine x according to rule 7. To solve things easier and save more time, let us factor the function out so we can apply the product rule just once only. Afterwards, we need to multiply the function with its derivative diagonally for the product rule, and then put or add the products together. Then, combine or add like terms, and we have here the first derivative, which is e to the x of negative 2 cosine x plus 4 sine x, or we could also put the 2 outside. That being said, the derivative of e to the x and negative 3e to the x.
To find the second derivative, we need to find the first derivative. This is denoted by d squared y divided by dx squared is equal to d divided by dx. Since we already have our first derivative, we will find the derivative of that function in order to find the answer of the second derivative. Just like what Ms. Sideriosa said, we need to apply the product rule, rule number 8 and rule number 7, in this kind of function. 2e to the x stays the same according to rule number 8. The derivative of sine x is cosine x and the derivative of cosine x is sine x according to rule number 7. Afterwards, we need to multiply the functions with its derivative diagonally for the product rule. And then, put or add the products together for the product rule. Lastly, combine or add like terms, and we have here the second derivative, which is 2e to the x of cosine x plus 3 sine x. And here we have the final answer.
Thank you so much, Miss Despi, Miss Sidoriosa, and Miss Elia. I hope you guys have learned something from today's session. Once again, this has been Miss Getchon, and always remember, with Calculearning, it's amazing. Until next time, bye!